Now what we try to do is we incorporate these hyperbolic time preferences in a general equilibrium framework where you have both capital and a climate asset, climate change cycle, carbon cycle with climate change. And then we want to see if you have these hyperbolic, quasi-hyperbolic preferences, what happens with, say, optimal policy. And we find that these quasi-hyperbolic preferences actually give you or can give you the capital investments which are consistent with what you observe, and at the same time give you very high carbon prices which are consistent with, say, the argument from Stern. So what is new? We have the literature, we have some literature on quasi-hyperbolic preferences, but this literature tells us that it's inefficient to have differential discounting for different types of assets, for capital versus nature. We actually show that what are the conditions when it's actually better to accept differential discounting, different returns for capital versus climate, versus that you enforce on your system that there must be equal returns. So one of the analysis we do is we say, now let's assume that you say, because of efficiency, we must use the same discount rate. We must use the discount rate that you can find from the capital market also to evaluate our climate policies. If you implement that as a policy, we find actually that welfare decreases. We have borrowed from the literature, we combine, we built a model that combines in a certain way the features of the DICE model with features from the model by Kolosov and Crusell and colleagues. So we have a model that's fully tractable, we can solve it completely analytically, but it also has quite a good physical description of the carbon cycle. So it also is in that sense comparable to DICE. In a certain way it's even, we think in some respects we may even improve on DICE in the sense that we have, our climate change is more persistent than in DICE. And we think the natural sciences literature suggests actually that climate change is much more persistent.